Welcome to the lecture series on soft computing in computer science. We are seeing the concept of a deep neural network, one of the major breakthrough in the neural network research. In the previous presentation, we have discussed till the ReLU operation, right. Now coming to the pooling operation. So what is the pooling operation? The pooling operation, again it is a kind of subsampling operation, that is it is interested to choose a portion of the image from the whole set. Already based on the convolution operation, the image size is reduced based on the kernel size. Now based on the stride value, the image is again reduced to a smaller size, or the image sampling has been taken, subsampling. Say for example, see, this is a image. What is the size of the image? This is a 4 cross 4 image, am I right? Say for example, if I choose a pool of 2 cross 2, I have to divide this 4 cross 4 into 4 quadrants. This is one quadrant, this is second quadrant, it is differentiated with respect to color, this is third quadrant, and this is fourth quadrant. So 4 quadrant it has been divided. In each of the quadrant you have to apply max operation, and the resultant value is chosen and it is retained as an output. So what is this? 1, 2, 6, 4. So what is the value? What is the maximum value? It is 6. So the 6 is printed here. Next to the again 4 values, 3, 2, 7, 6. What is the maximum value? 7. 7 is, so accordingly you should do it for all the other stride sizes. So what is pooling operation? The pooling operation performs a downsampling or subsampling operation that tries to reduces the dimensionality of a huge feature map, but retains the most important information, right. So that is the major idea behind pooling. So what are needed in order to do a pooling operation? You need to define the stride size. Stride is nothing but the sliding window size, and the pool, whether it is a minimum pool or maximum pool or average pool. Here the operation listed is a max pool operation. So that is according to the number of values available in the stride, we have to choose a value that is either maximum or minimum value. So that is the pooling operation. The final task of the convolutional neural network model is classification, that is fully connected layer. Fully connected layer, what it is? So it is a normal flat feed forward neural network. So it is not one layer, it is a neural network, and it is the feed forward neural network trained by backpropagation algorithm, what we have seen so far. So until now we have seen certain operations, and those operations are convolutional operation, ReLU operation, pooling operation. All these operations objective is to reduce the dimensionality of the image, that is feature extraction, followed by our 80s era widely used network, that is shallow neural network, that is treated as a fully connected layer here, right. So that have a non-linear activation function or a soft max optimization function in order to give output probabilities of class prediction. The major job of this layer is it will take an input and it produces output according to the operations that is performed previously, that is conv operation, ReLU operation or pool operation. So this is the, and it is prepares itself to do the task of classification. So this is the fully connected layer. So the fully connected layer is doing the task of this one. So you may treat this as input layer, hidden layer, output layer for our general shallow neural network, that is a neural network trained by backpropagation algorithm. Since the nonlinear activation function, softmax function is used, it will give the probabilistic value. So this is what the fully connected layer, that is the layer that is doing the classification task. So overall I wish to present once again the summary of CNN model. So, what is the major points we have covered in the convolutional neural network? First, we should provide the input image into the convolutional layer, choose the appropriate parameters, apply filters with the strides as well as padding if it requires, perform convolutional operation on the image, and followed by the convolution operation you should apply a ReLU activation to the matrix, perform pooling to reduce the dimensionality of the image, and as many as convolutional layers until we satisfy. So, convolution, pooling, ReLU, that has to be continuously performed with a lot and lot more number of layers until the desired as well as the expected features, that is most important features from the image has been chosen. Finally, it is entered into a flattened layer, that is a fully connected layer from which we will going to receive the output by means of a nonlinear activation function, that is softmax function, and that will produce the probabilistic value that is very helpful to classify the image. Again the pictorial summary, we are given with the input image, and this input image is subjected to convolutional as a ReLU operation. We are interested to produce feature maps, we are interested to produce feature maps, interested to produce feature maps, interested to produce feature maps. So, until all these tasks are going to be feature extraction, followed by you are doing the classification, right. So, when a image is given, I want to analyze this particular portion of the image. What is this portion? So, what is this portion? Boat, it is 4%, house 5%, tree it is 90%, and cat it is 0.1%. So, that is the thing, finally that. So, there are various development has been occurred in the CNN even till now, till today. So, this picture will give you the major breakthrough in the model. See, in the year 1988 to 2011, there is a model that is find out and has been popularly used called LeNet. So, this is one where the CNN becomes available from the year 1988 to 2011, this neural network has been covered. And from the year 2012 to 2013, we have formed a come with a net called AlexNet or ZFNet, and this AlexNet or ZFNet has been released with the help of the competition image net competition, and it is otherwise also called the ZFNet. And in the year 2014 to 2015, we got 3 more neural network model, GoogleNet, VGGNet, and ResNet. And in the year 2016, we got another layer called DenseNet, densely connected convolutional neural network. So, see, these are all the various developments in the convolutional neural network model. All these developments has occurred due to some kind of data challenge competition. Very popularly the competition is what is that, ILSVRC, ImageNet. So, that is the basic idea behind the various developments in the different kinds of neural network convolutional neural network models. Of course, still more models are available. This is the one which lists the major highlights of the neural network model development, right. The next important model is recurrent neural network. So, by the name recurrent, you may come to understand that something is given back. The connection is something backward. Yes, of course, it is also a 3-layered structure where you may have a number of hidden layers, but the thing is it has one feedback connection. This feedback connection will present the output as one of the input. The output at a time t equal to 2 will be present as a input at a time t equal to 3. So, when time t equal to 1, there are certain inputs and it goes to the hidden layer and it goes to the output layer and it produces the output at time t equal to 2 and it is fed as input to the time. So, likewise the recurrent connection is there. So, this is very popular yet another deep neural network, but if you could see that the architecture is showing it is not a deep network, but it is a simple flattened network, consists of input layer, hidden layer, output layer, and each node's layer is doing the two tasks, summation as well as activation, summation as well as activation. But how this network is converted into a form of deep network, let me go through the presentation. See, this recurrent neural network falls under the category of deep neural network because of the enormous layer connections which may be seen here. See if you have a model like this, and if you expand the hidden layer may be increased to. So, the hidden layer is respected to various timestamps. The hidden layer values changes. Of course, why? The input layer is given to, so the output layer is given back to hidden layer. So, at t equal to 0, the hidden layer is one set, at t equal to 1, the hidden layer is some other value, and so like that, based on the feedback connection. So, the popular algorithm used here is the same backpropagation algorithm, but with respect to time. So, this algorithm is called as BPTT algorithm. So, it is an algorithm for updating weights in a recurrent neural network to minimize the error of the network output. So, for every recurrent network there is a feed forward network with identical behavior, that you should remember. A recurrent connection is nothing but a feedback connection that will affect the output from the network using subsequent iteration. So, over the period of iteration. So, how it is useful? So, it is useful for some sequence of events. There are some data which have, say for example, you may have speech, you may have signal, you may have waveform, and you have video, and you have audio, and you have text. See, these are all going to be sequence states. The state gets changed, for which you need a training, you need a memory, right. So, this is a recurrent neural network. So, how can we define this recurrent neural network? So, given a standard feed forward multi-layer perceptron network, a recurrent neural network can be thought of addition of loops to the architecture. That is the important point, that is you need to do. With respect to convolutional neural network, it is addition of more number of layers, and each layer is responsible for its own task, whereas with respect to recurrent neural network, it is addition of loops with respect to the states, that means timestamps. For example, in a given layer, each neuron may pass its signal laterally sideways in addition to the next layer, that means feedback. The output of the network is fed back as an input to the network with the next input. The recurrent connections is going to add some state, that is t equal to 0. At the time, what is going to retain? Memory or memory to the network, right. So, the input to this recurrent network is a sequential data. So, what are the examples for sequential data? Audio data, video data, sometimes a text, but text have some other additional thing with respect to NLP is required. So, those are all the data, sequential data. So, that you should remember, right. So, how the recurrent neural network is different from the normal neural network? If you could see the normal neural network, you have the input layer, hidden layer, and output layer. So, you know there are 3 layer in general it is having, and you can have any number of hidden layers, but it is not with respect to the state. All hidden layers are having the same state. See, set of input layers, hidden layer, and output layer. So, this is the normal neural network. But when you look at it, the recurrent neural network, look at this hidden layer node, look at this hidden layer node, there is a connection. It means the hidden layer is getting the input from the output, and it is having many state H0, H1, H2, H3. For all the cases you have, see, x1, x2, x3, y1, y2, a3, but the state is getting changed. So, when you take the input and output with respect to a normal neural network, it is of vector type and it is fixed size, but it is a series type and it is variable size, that you should know clear meaning. Multiple different weights, see each and every node, this W11 is different, having different value, this see each and every weight values, is having a different weight values, weight parameters have different weight values, but same weights is applied over and over with different items, but the state is differing. Weight values are same, but the input values are differing because the output is fed back to the hidden layer. So, that is getting differing. So, outputs are produced with the weight updation alone in case of the normal neural network. What is normal neural network here? That is shallow neural network, right. So, but here the outputs are produced not only by the weight updation not only is there, but the output value is also fed back. So, that you should think about again and again. So, no parameters, see here we don't need any parameters across the layers, no parameters sharing, is required, but here the parameters are shared. So, in summary, a normal neural network will becomes a recurrent by introducing a hidden state, not by hidden layer. We are introducing the state, that means we are introducing the loop, links one input to the next repeatedly by applying transformation to a series of given input for producing the series of output. So, it is a sequential input data and it is producing the sequential kind of output. So, that is the fundamental difference between the normal as well as the recurrent neural network. Now, how to increase the simple neural network into a deep neural network, that means how to add depth. So, depth here that is added by means of adding the state, right. So, that is the idea. So, the introduction of hidden state enabled us to effectively identify the relationship between inputs, right. But how can I make a simple RNN to behave like a deep RNN? We may have enormous amount of state. Will the state alone is sufficient in order to make that simple recurrent neural network a deep neural network? You need to think about it. So, we want to have or we want to gain multi-level of abstraction as well as representation. Will that be sufficient enough just by adding more number of hidden states? And if it is added, how it is added? So, we have to add, we can add hidden state one on top of the another. So, hidden state 0, hidden state 1, hidden state 1 on the top of the another, and directly it goes to the output. Or see one or the other another we can have the connection here, see. So, this is one hidden state, another hidden state is, so 1 over, see H is one hidden layer and Z is another hidden layer, over which we can have A as another hidden layer and a B as another hidden layer. So, like this can keep building one over the other, or add additional non-linear hidden layers to the input function. See additional non-linear hidden layer, this hidden layer you can add additional non-linear hidden layer, this hidden layer, or increase the depth in hidden to hidden transition, see. So, there is a loop, right. Here you can add hidden to hidden transition WH, or you can increase the depth from hidden to output transition WY. So, first thing I have already H, that is a hidden layer, I can add another hidden layer is that over the above. I have a hidden I have a connection between input and output, I can add the transition here, or I can add a transition between the hidden layer, or I can add a transition between input and output. So, in that way you can keep increasing the depth from for a simple recurrent neural network to a deep recurrent neural network. See, with respect to different application domains where the deep RNN has been applied, we have different flavors. So, 1 to 1, that is one input layer and one output layer, like that. So, this neural network is treated as a simple vanilla flavored model and it can be used for normal image processing, how the CNN model is used. So, it has a fixed sized input to a fixed size output. So, in general it is used for image classification, but there is a second flavor model, it accepts one input and many output. So, when you look at this model, so this particular model what task it is a sequence output, that is input is fixed, but the output is sequence. So, for what kind of applications it is very essential? It is essential for the case of image captioning. What is image captioning? When you give an image, say for example, if I give my image, it has to say this is lips, this is ear, this is hair, this is nose, like that. It has to give various captions. For a single image, it has to produce many values to the output. So, that is the second case. And what is the third one? It is many to one, that is many input, but only one output. Very particularly, it is very particularly used in a kind of application called sentiment analysis, or it is otherwise called by the name opinions. See, whenever incident has happened, one post many what can I say, opinions, right, their opinions or their views or their comments, like that, right. So, according to the comment, so the comments has been processed, and finally one thing is happened, whether it is positive or it is negative, or whether we can go or whether we can't, like that, do or die, that kind of model. That is a 2 layered model, sorry, 2 category model. So, it is many input and one output category. And third one is many input many output, and fourth is also many input many. So, but the difference is, see, sequence input and sequence output, synchronized sequence input, that is the main thing, sequence input and sequence output, that is this case, that is the fourth one. And what is the fifth one? That is synchronized sequence. What is that? Machine translation. The application is when you type a text, nowadays you may find that when you type any text in WhatsApp or when you type any text in the Gmail, it will give you the word that you want to type. Say for example, good, if you type, automatically it will give morning, right. So, then if you press a simple tap, it will you no need to type that morning and all, right. So, that is the kind of thing, that is called machine translation. Or otherwise you can say with respect to that, if you give any sentence in English, it will give the corresponding word in other language. So, one language has been transferred into another language, that is Google Translator is basically working on this particular model, many to many, that is sequenced input and sequenced output. But what about synchronized sequence input? So, this is video classification. What is the next scene? What the next player will do? It will be used for many game analytics. Say for example, in a cricket game you are going with the third umpire decision, right. So, when you want to go for third umpire decision, you need to say how this decision has been happened, and you can recall the everything. So, you have to analyze the video frame by frame. What is the next one? What is the next one? So, that kind of thing maybe use this kind of model. So, these are the different deep recurrent neural network model one can go for using this idea, right. Next, of course, all models come with a lot of challenges and lot of limitations, and RNN is also not the one which is not having any simulation. It is also having so many things. One is short term memory, another one is vanishing gradient, another one is exploding gradient. What is short term memory? See, I already said that it is having some feedback connection to the hidden layer, right, but this layer is also doing the task from the input layer. Here this input layer is there. So, while doing this task, this layer should remember the past the input, that is the past output from the output layer. So, sometimes due to the shortage of time, it may take lot amount of calculations for processing the regular routine work, but it failed to retain the model. So, that means very short amount of time is there for memory to recollect or to restore the output value. Sometimes based on the complexity of the calculation, that output that is given back may get vanished, may get erased. So, that you should address the short term memory, right. Another one is vanishing gradient. I already told that it is a gradient descent method. According to the gradient descent method, the weight gets either increased or decreased according to the error value. When the error is keep on decreasing or whether the error is oscillating, according to that weight is changing. Suppose you are keep on reducing the weights based on the performance of the model, but sometimes the weight value get reduced, get reduced, get reduced, get reduced, and it is entered into vanishing. That means it gets completely gone off, vanishing gradient. So that is the first kind. And another one is exploding gradient. What is this exploding gradient? So when you keep on exploding, increasing the weight one by one, one by one, one by one, one by one. So at one point after the weight explosion happens. Until for that there is no more weight updation and your neural network source of the poor performance. So these are the two problems, vanishing gradient and exploding gradient. Due to decreasing of weight size, it may go 0 or below the 0, and it may go the maximum or more and more maximum value, that is exploding gradient. So these are the three problems associated with the simple RNN. In order to address that, we are going for LSTM, long short term memory, for addressing the short term memory issues, as well as GRU, gated recurrent unit, in order to address the vanishing and diminishing gradient. So what is this LSTM and GRU? So they were created as a deep recurrent neural network solution providers to avoid the problem of short term memory, vanishing gradient and diminishing gradient. So what is that? They have some internal mechanisms called some gates. So if you could find that there are some internal mechanism gates which is doing the sigmoidal function, which is doing the tangential function, and these gates can learn which data in a sequence is important to keep or throw away. So they know what has to be done, that gates. By doing that, it can pass relevant information down along the chain of sequences to make predictions. So it will always tries to know like some kind of attention is there over the good number of variables, some kind of distraction is there for the unknown variables, and it will remove that or it omit that. So almost when you take the case of RNN, these two networks, that is LSTM as well as GRU, is very well applied in speech recognition, speech synthesis, text generation, and furthermore even for video recognition. So we started with the recurrent neural network, and it is a simple network with having only feedback connection, but we can keep on adding the different flavors with respect to different application domains. We have different models of recurrent neural model. Overall, the RNN model is facing three different issues, and three different issues has been well addressed by some models like LSTM and GRE, but still this LSTM and GRE is having limitations, and in order to address those limitations, they are having further more models also. I think how you come to know about the idea of deep neural network. So this lecture discusses about the advanced as well as the most common form of neural network, that is a deep neural network. Out of that we have seen two categories. One is a convolutional neural network, another one is recurrent neural network. So those two neural networks now got the entire world in the artificial intelligence era, and it is widely applied to many of the sectors across the many problems. With this, I think you can have a simple glance about the advanced models of these two neural network. So I expect you to understand the idea behind it, and in the next session we will see something related to the coding, how the MATLAB code can be developed for a CNN model and a RNN model.